Hi guys, so this is the part 2 of the homework, and over here we're going to code and explain a function that will going to calculate surface points on the elliptical cross section of the helix. So, what we're going to do, okay? So this is the we're going to put a function. So in the previous part we derived a function, we coded a function called Fresnel array, which takes one function and in terms returns two functions which are tangent and normal. And now we're going to use this tangent and normal function to get the surface point. Okay, so this is the part two. We're going to create another function. We'll name it as surface, and it will going to create surface points and elliptical surface points on the along the way of the helix. Okay, so let's get started. So this was our helix. So it was for the demonstration purpose. So I'm going to remove this now. It's not needed anymore. I'm going to proceed further. So before proceeding, we need to make some changes in our codes. Like we need to convert this into an array. So let me do it. jnp.array, and we're going to convert this numpy to jax numpy because we'll be doing the uh, you know Jacobian and calculating the tangent, all these things throughout the surface. So we're going to pass this function. So we might face issues if it is in numpy. So we're going to convert this into numpy, jax numpy. Okay, so it looks good now. And then okay, so let's define the function called surface. So surface will take two parameters, two arguments, e and theta. Okay, so already got two functions which are tangent and normal, which are the output from this Fresnel array function, where which will take helix as an argument and give these two functions as output. So let's save them as t for the tangent tangent function's value, a particular value small t, will save the value in capital T. Similarly, we'll save the normal at some value of t in capital N. Now, let me show you this thing. Okay, so I was talking about in the previous part, I was talking about the vector. So let me draw it again more clearly. So here, this is the curve. Okay, so we got the tangent vector, we got the normal, and we need to find uh, a base vector. Okay, this is the tangent, this is the normal, and this is the base vector. And to find the base vector, which is perpendicular to both normal and tangent, we'll do a cross product. As you can see, we'll do a vector cross product, means n cross t, it will come like this. So it will come from this to this. So like this, we will right hand thumb rule. So it will going to point outwards. This is the b vector, the base vector, and this is the normal vector. Now we're going to use this base vector and the normal vector to get the surface points on the along the ellipse. Okay, along the helix, the elliptical surface points along the helix. So let's define that. Let's get the let's write the uh, base vector first. So base vector is nothing but, so let's take it as T B, capital B, is equal to JNP dot cross product of. It's an inbuilt function to find the cross product of any two vectors T comma N. Okay, so that's fine. Now here, what you need to see as, let me erase this. Okay, okay. So if you find a point over here and over here, okay. to find different, to find the circular points, to find, different points over here, you need to change the angle of theta. For example, this is, there is no angle. This is, you take a point. If you want to get a point over here, if you take some angle theta and rotate this by angle theta, you'll get this point. Okay. And similarly, you do another theta, you'll get this point. And again, another value of theta, I'll get this point, this point. Like this, you're going to get circular, elliptical points. If you just connect them, you will get in perfect ellipse. And we're going to define the radii, which is given already, major and minor radii. And to do this rotation, I need to we need to make a matrix, which is called rotation matrix. Okay, let me tell you what is that. So, for example, take some coordinate system, something like this. Okay, now we want to rotate it by an angle of theta. Okay, so this is theta. Now we need to find these values. Okay, so it will be, if you take like this, so it will be become sine theta. Okay, and this will be cos theta. Similarly, if you do here, this will become minus sine theta, and this will become cos theta. So these are the points like cos theta and sine theta, and this is minus sine theta and cos theta. Okay. So if you want to write it in a vector form or a matrix form, it will become, let's write it some R vector or something, R matrix or something. So it will become the I and J components are like, stop working. Okay, so the I component and J components are, the I components are cos theta and sine theta. Similarly, for this, it will become minus sine theta and cos theta. Okay, now let's take an vector over here. Let's take vector v, okay, which has coordinates like 1 and 0. So it will be 1 and 0, right? It will be 1 I cap plus 0 j cap, something like that. So if you just convert into a matrix, it will be 1. Let's convert it to a row matrix. I'm sorry, a column matrix. So 1 comma 0. Okay. So to get the value of this thing, this is nothing but a linear combination of this rotation matrix and our this the vector, this vector. Okay, this matrix. So this is nothing but the linear combination of this rotation matrix and whatever vector it is there, you want to just rotate it, just do the matrix multiplication. We'll get the linear combination of that vector, that matrix with this rotation matrix. So this is the simplest method. Like whatever vector you want, just do the or a matrix multiplication with this rotation matrix. Okay. So now we're going to use this formula, this concept, to get different points over this, over this surface. Okay, over this point, over different surface points. So for different value of theta, we'll get different points. Okay. So let's make a function called what do you call rotation matrix. Let's call it rotation matrix to take argument theta. Okay, that like just to simplify, let's take GNP C is equal to GNP cos theta, S is equal to GNP dot sine theta. Okay, and it will return rotation matrix. Let's return it in a array form. Okay, so what are the components over here? Cos minus sine, cos comma minus sine, then sine, then cos, sine, then okay, it looks good. Okay, we got our rotation matrix. Now what we'll do, we're going to define a vector which which is going to a vector of 1 and 0, just like this. Okay, so 1 and 0, column matrix of 1 and 0, we're going to cross multiply and do the matrix multiplication with the rotation matrix to get different values of the, okay, to get that vector at some angle theta, convert it to angle theta. Okay, we'll just do the matrix multiplication of that. So let's take V is equal to rotation matrix. You just need the rotation matrix at the angle theta. We're going to provide then matrix multiplication of an array of 1 and 0, just same like this, but it's in, it's a row matrix. We'll convert it into a column matrix, like two rows and one column. Means two rows will be there and one column will be there, so it will be column matrix. Means one component will be here and the component will be here, just like this, okay. Now we got our vector V. Then now let's return the value of what we're going to return. Okay, so we got our matrix, we got our vector. So see, now we got our vector. Let's take another point. This is the helix. We got this n. We got this b. Now we got this. We got our vector v. Okay. Now once we got our vector v, we can calculate angle theta we got taken. Okay, whatever angle you want, you can take. You can rotate this vector v whatever angle you want. But in our question, it's given like we need to take proper, what do you call, proper red eye. Okay, so this vector doesn't have any direction, so what we're going to do, we'll go in this direction. We're going to multiply this vector, the normal vector, multiplied by that vector is the this vector v, and we're going to provide it a particular length. For example, it's a. Okay, similarly, we're going to do that with the b vector. B, okay, means the base vector, so it will be 0.5. Okay, so let's do this and we're going to see what's going to happen. So it will become A. Oh, I have to define points over here. Got some error? No, it's fine. Okay, so let's define A is equal to 1, B is equal to how much? 0.5. Let's make it as in float point values, because sometimes JAX only takes float point values, so it should not throw any error while we're doing compiling. So anyways, A into B into, okay, the first column, the first row of this vector, whatever value is there, means the what do you call, the cos and sine theta of the first column, first row, this vector, plus B into n multiplied by V of 1 is the second row of this vector. And now at last we have to give some origin point where it is going to start. If you don't give anything, it is going to start somewhere else. So we are going to give the origin point our vector of our helix, which is this point. So we're going to give our helix over here, P comma R comma NG. Okay. mg and r are already defined. So let's see. Okay, it's perfectly fine. There is no error. So let's see some point at some value. Let's say at 0 and theta and p dot pi maybe at pi by 4. Let's see what are the values are coming. Tangent is not defined. Okay, let's rearrange. Okay, what's there? Surface. Okay, let's see what's the error over here. It's not giving any error. Helix. It looks fine. Rotation matrix. Surface at 0, comma theta. Let's give JNP dot pi by. Okay, I got it now. Theta value. Okay, function object is not subscriptable. Okay, let me see what's happening over here. Let's give only one argument. We'll see what it's saying. Using one argument. P dot pi. Okay. Normal is okay. Forget the parenthesis over here. That's why it's saying here. Not sure. Location. Rotation matrix theta. That JNP dot array. Receive. Okay. We'll see. Should not give error. Surface. Let's give 0 and NP dot by 2. Okay, still giving error. Okay, so for passing 0 as d and theta, it's calculating the values of this is right. Cos minus sine theta, sine is cos theta. This looks right. Where is the error? I don't know. Uh, Surface d theta. Function will take two arguments. Why it is not taking? Maybe I missed somewhere something. Not subscriptable. Well, let's see what is not make sure you only call the method of a class using curly brackets and you use square brackets to call class. Okay. There is some syntax error, definitely. Method object is not successful. Error is raised when you use square brackets to call a method inside a class. To solve this, make sure you only call methods of a class using curly brackets. Okay, Python is okay. Redundant identity method. You need to use parentheses, mileage insert. Okay, maybe I've missed some parentheses somewhere. Mileage, okay, maybe I missed some parentheses. Definitely, that's what I'm getting this error. Receive, I don't know where's the error. Okay, simple. Okay, so in the next part, the third part, we're going to vectorize the function, and we will see. We'll try to fix this error in the part three of the homework. So we are supposed to do a vectorized function of this and pass the different arguments. So catch you guys in the part three of the homework.